Hi everybody, Mr. Rubo here, and today we're going to look at piecewise graphs. So specifically on our notes, page 25. Pulling up Desmos, you would do all this by hand, but I kind of want to just kind of like talk at least the beginning part um, about how this should look or like what's happening here. So if we look at the very first example here, we have what is called a piecewise function. It is a function where there's multiple equations based on different domains. But we look at the graph as a whole. Okay, so you'll see what I mean by that in a second. But just for the sake of kind of like seeing some of this, so y equals 5, which is that first equation. Actually, I'll even throw f of x equals 5. Right, it's a horizontal line at 5. The second part of it is telling us what the domain of this piece is. So it's saying the domain is all of the x values less than -2. So if you can kind of see here, I'm going and going, and I get to -2, and I can't really click on it because it's technically an open circle, but it's all of these are 5 until you get to -2, and then it stops. That piece of the graph is done. Okay. And then the same thing happens with the next piece, right? So f of x equals 2x plus 1. 2x plus 1 means y-intercept of 1, slope of 2, so it's a straight line. But it says -2 is -2 is less than or equal to x is less than or equal to 3. And you can see, it's just this tiny part here. This time, because -2 is included, I can click on it. -2 comma -3 is that point. And then 3, 7. So there we have this section. And actually, I'm going to change. What do I want to do? That's fine. And then our last section, same idea. X minus 6. Well, that would be a line again where y-intercept is -6, slope is 1, but this time I just want the piece that is greater than 3. Okay, and you can see it takes this piece again at 3. Ooh, look, it even says it's undefined if I can actually click on the point, and then it just keeps going forever. So this whole graph is the piecewise. Okay. So again, that's my Desmos explanation of just like what's happening. You have the full line graphed, but then you're only taking a piece of it. Okay. So how would you do that without having Desmos? Well, you just have to know how to graph each of the pieces separately, which you know how to graph lines, so I'm not too worried about it. But what I like to do is I look actually at the domain first. So I see that, okay, at -2, I should have a switch from one piece to the other. Then my other switch happens at 3. Okay. And now I just start plotting, I start graphing each of these lines. So, okay, just want to make sure that was right. And again, you just think of them each separately. So f of x equals 5. Well, that's a horizontal line at 5. But once I get to -2, because it's less than, it's an open circle. And because there's no other bound on the left side, it just says less than, I'm going to go forever. So I put the arrow. So there's 5. That one is now done, that piece. Now I switch to the middle one, -2 to -2 to +3. So now what I would do, and especially if it's a line, I would actually just plug in these two values. Okay, because since it's a line, that's going to give you the two n values of it, and then you just connect it in a straight line. So do a little math on the side. Right, 2 times -2 plus 1. Well, that's -4 plus 1, so -3. So -2, -3, and it is a solid circle or filled in circle because it's or equal to. And then do the same thing with 3. So 2 times 3 is 6 plus 1 is 7. So 3, 7 way up here. And then again, connect them as best as you can in a straight line. The other way you could also done it is once you figure out one point, whether it's the y-intercept, which actually my y-intercept is off a little bit because I can't draw a very straight line. And I do want to make sure it does go through that point. There we go. That's better. So you could use the y-intercept, but sometimes the part of the graph you're looking at doesn't include it. So once we found this, we could have gone up 2 over 1, 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 and figured out all those points until we got to the very edge, right? So that's why I like putting those dashed lines in first, because I know where each piece starts and where it ends. Okay, so then we're going to do the same thing with x minus 6. Well, let me plug in 3, because that's where it starts. So 3 minus 6 is negative 3. So negative 3. Now this one is going to be an open circle because of that. Oops, I missed it. Because of that. Then this one, because I could plug in another point if I wanted to, but I can also just use the slope up 1 over 1, up 1 over 1, connect, and draw the arrow. And here is your graph. All right, so now we've actually been doing this already. We just weren't necessarily graphing them, but it's good practice to remember how to write increasing, decreasing, constant, local max and mins, and then domain and range. Okay, so increasing, you look at this graph and they are increasing from negative 3. I'm sorry, that's not negative 3, that's negative 2, up to 3, and then it increases from 3 to infinity. Now, this one, it's a little interesting of an example because of the fact that it is still increasing, but you're from this point at 3 down to here, it actually like jumps down a lot. So that's why I would just have it as 2 separate intervals. Had it been increasing from the same spot, then I would have it as 1. Okay, decreasing, there is none. Constant, well, that would be from negative infinity all the way to negative 2. Because again, you're looking at this section over here. The x values from negative infinity to negative 2 give us that. Local min and max, there are none because we don't have, remember, local max, you have to have the hilltop or the peak, where the local min is the valley or the bottom of the V. Okay. Now the domain, you can either use your graph, depending on what equations they give you. You can also use like this. So it's saying, okay, from negative infinity to negative 2, not inclusive, but then it's included down here, which means in the whole graph, negative 2 is included. Then from negative 2 to 3, it's all included. And then from this part, 3 is not included, but we already included it up in the other one to infinity. So this domain, negative infinity to infinity. Okay. Now let's look at the range, because the range is usually the tougher, I feel, of piecewise graphs, because you have to make sure you have graphed it correctly and you kind of go off the graph. So you look at this and you're like, okay, my lowest y value is negative 3. This solid point here. Yes, there is an open circle at negative 3 as well in terms of the y. Solid beats open. So negative 3 is included, and it is my lowest value. Now, if you follow this one, okay, it goes all the way up to about 7. Not about 7, it goes to 7. But again, you're looking at this graph as a whole, and this section over here goes up to infinity. And so it goes to 7, but then it goes past 7. So then we're looking at the graph as a whole. So it starts at negative 3 inclusive and then goes to infinity. Like I said, it usually range is the trickier one because you could have gaps, or you can have situations like this where you have overlaps. And again, overlaps always throw students off with how they denote it. Okay. All right, so let's go ahead and try g of x, and then I'll leave the last one for you. So this one, it's saying Again, I'm looking here first. -5 is actually my big boundary. There's nothing smaller than -5. And then -2, and then +2, and then 4. So I should have graphs in each of these sections, but then the other thing is I actually don't have anything on the outside parts because they do end. All right, so let's go ahead. Let me change colors. We'll go blue here. So the first one, again, because it's a line, right, it's y equals mx plus b, I can plug in -5. So if I plug in -5 for x, I get that. -5 gives me -10. And then again, I can do one of two things. I could plug in -2, or I can use my slope and just go up 1 over 1, up 1 over 1, up 1 over 1. And make sure you pay attention to these. They are both solid circles, which is what I've done already. So there is this section, and I'm done. Okay. Now, the middle section is going to be the most difficult because it's not a line. X squared, we talked about this last week, is a u. So this one, you might need to plot more points. Okay, and you might be able to do this in your head. -2 squared is 4. Then maybe you go -1 squared, which is 1. Then 0 squared. Then 1 squared. Then 2. Okay, and you can kind of see here my shape is this u. And I did make a mistake here. The mistake happened with these endpoints. I should not have made them solid. I should have made them open circles. And the reason open circles, again, because those are less than symbols, not less than or equal to. Okay. And then the last one, 2x plus 1. Again, I like to substitute in the 2, right, the low end. So that's 4 plus 1, which is 5. So at 2, I'm up here at 5, which is going to make the range interesting. And then again, I can plug in 4 if I wanted to, or I can just go up 2 over 1, up 2 over 1, and solid circles, and connect. Ooh, pretend it actually went through there. Straight edges are really useful. All right. So again, this is one of those cases. Let's talk increasing, decreasing, constant. So increasing, well, it's increasing from -5 to -2. And then it's again from 0 to 2. And then again from 2 to 4. Okay. So we have all of those sections where it's increasing. Decreasing is just this little part of the u. So from -2 to 0. Okay. And constant, it is never constant. So there is no constant section. Local max, there is no local max. Local min is at 0, 0. Okay. And then our domain, again, you can either look at the graph you've made or look at what's here. It's saying x is between -5 and 2, inclusive, -2 to 2, exclusive, 2 to 4, inclusive, which really means it's inclusive from -5 to 4. And that's also the case if you look graphically. Now the range, like I said, this is the one that always throws students off. So the range is the y values. So you look at the lowest y value, it's -10. Close circle, so square bracket. You then move up on your graph and you get up to -7, and that's where your graph kind of stops, and then it jumps. Because we have this jump all the way up to 0 is the next x value or next y value, we have nothing between 0 and -7. We have to have a second interval. So then from 0, we go up all the way to 4. Now, both of these 4s are not included. So we'd say 4 parenthesis. And then we have this next little tiny jump. It goes to 5. 5 is included, and then it goes all the way up to 9 in terms of the y values. Okay, so there's our range. Again, usually that's the hardest part for students, is writing out the range correctly, especially when there's jumps. And by a jump, I'm talking about from this y value to this y value. There's nothing. So this y value and this y value. There's nothing in between. No points in between in terms of y's. So you have two separate intervals. And then, again, you have it here as well in that little section. All right, so try h of x. You can put in Desmos if you want to double check to make sure you've done it right. But go ahead and try that one. Pause this video and try that one out on your own. Okay. And now let's go to the next page, which is now working backwards. So we have two graphs here, I believe. Yep, two of them. And I want you to write, it says write the definition for each function, which literally just means write the function. Okay. So when we look at this, I'm going to start by saying f of x equals, and then have squiggly brackets. And we look, and this, I like to kind of work the same way as if I'm graphing them. I see where the graph is changing. Okay. So we have these three graphs, right? So we have this line, this decreasing line, this constant line, and then this increasing line. So I need to come up with the equations of these, but before I even do the equations, I'm going to do the domains. So I know the first function, this leftmost function, is from -8 to -5 in the x direction. So it's between those two. So it's less than and less than. And then those are filled in circles. So it's less than or equal to, and then less than or equal to. Then the middle section, well, this one is actually interesting because they share this point here. So at -5, you could say less than or equal to, or you could just say less than because we've already included the or equal to part in the first equation. It doesn't really matter. Either way is right. And then, but on this end, we would have to say it's less than 1 because it's an open circle, clearly an open circle, so less than 1. And then the last section is from 1 less than or equal to x less than 5. Right, so open circle up there, closed circle down here. All right, so now we have to come up with the equations of these and make sure you put them in the right spot. I always like doing the easy one first just to get it out of the way. So we have this horizontal line, which is the middle one, which is the horizontal line at -4. So that one's done. That's done. The other two, well, we can use our knowledge of lines to figure these out, but that's why I give you so much room here. You do need to figure out the equation of these. So when I look at this, I see 2 points, so I'm going to count my slope. So 1, 2, 3, 4, 5, 6, 7. So down 7 and over 1, 2, 3. So for this first line, I know it's y equals -7 over 3x plus b. Okay. Now the question is, what is my b value? Well, the b value I have to solve for, so you could put it in point slope form, but because we want it y equals anyways, what I'm going to do now is just take one of the 2 points that I know, which are either one of those, and substitute it in for x and y. Right, so you guys have done this before. It's nothing new. I will say these numbers aren't the greatest, but that's okay. It happens. Fractions are okay. So that's 56 thirds plus b equals 9 thirds. And I'm just going ahead and getting the common denominator right away because I know I'm going to subtract. So I get that this b is whatever 9 minus 56 is. So what, 47 thirds? Yeah. So that means this top equation is -7 thirds x. That's negative. Minus 47 thirds. Really ugly number, but it works. Okay. And then we're going to do the same thing for this other one. I'll change colors just so there's no confusion. So again, I'm just going to count point to point. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So the slope is 6 over 4, which does simplify to 3 halves. So 3 halves x plus b, and then again, I'm putting in one of those 2 points. I'm going to choose the one that's got the smaller numbers. So 3 is the y, 1 is the x. That's 3 halves. And 6 over 2 is my common denominator. Subtract it over 3 halves equals b. So again, I now just put in the y, the mx plus b part. So 3 halves x plus 3 halves. And so this right here is, oh, that's annoying. This right here is your whole function. Yes, those 2-line equations weren't the nicest, but they're doable. They're not horrible. Okay. And if I were to put these 3 into Desmos, I would get the exact same looking graph. The only thing, Desmos doesn't really show the open circles, but the graph itself would look exactly like this with the increasing, constant, decreasing. All right, so go ahead and try this. This one can be done in 3 or 4 lines. Okay, so just realize that. So yeah, try this one out, and then check the answers on Canvas. And yeah, thanks for watching. Have a good day.